Today I'm here to kick off a new video series, a formal introduction to Cimatron Quick Electrode. You've probably heard of Cimatron Quick Electrode from people in the industry, either tool making or EDM, and you may be wondering, what is Quick Electrode and why do I need something like that? For users familiar with it, they already know. It's the magic that makes electrode design faster and easier. It's a product by Cimatron for designing electrodes, offered both as a standalone or an add-on module. It automates many of the repetitive functions used to design electrodes. It sets up the electrode assembly. It maintains color and height standards. It uses standard and specialized solid and surfacing functions. It automates documentation for electrodes and electrode assemblies. With an optional add-in, EDM Setup, it generates G-code for the Syncer EDM. I'm not going to tell you that users will be able to design and program 10 electrodes in 20 minutes, but I'll say it's likely to save you time. Over several videos, I'll be showing you what makes it special. With the dedicated tools and the smooth workflow, it's easy to recognize the potential for gain. The tools streamline and automate the boring and tedious work related to designing electrodes. Today's discussion, we'll start with the Electrode Setup Wizard. Then I'll design a simple electrode with surfacing functions. Then we'll mirror and copy to multiple locations. Let's jump right into creating an electrode project. I'll choose the Electrode Wizard icon from the toolbar to begin the workflow. The wizard is a tool that sets up the assembly and adds components of interest to the project. I'll choose the battery core and verify the project name and file location. Then I'll verify the general preferences like the color palette and the standard height rules to follow. Quick Electrode creates the assembly and adds the core I had selected. Notice the toolbar on the right of the screen. It will guide us through the design process. This core has 4 cavities, but for the video I'll focus on cavity 1 at the lower left. Using the extract electrode function, let's extract the first electrode. The system changes the display to my preferred settings and is ready for me to drop a blank. I click the location for the blank, then verify the surfaces I plan to EDM with, and hit my middle mouse button. Then I can adjust the burn location and OK the electrode. The system creates and activates the new electrode file in the assembly. Notice the guide on the right updated. It's laid out with the top-down workflow. First I create the blank. I have an option to resize and relocate the blank again. Next I'll chain together edges of the electrode. This lets the system know where I want to focus. Then I'll create extensions on each of the composites. Then I'll use Auto Composite and extended the blank to complete the electrode geometry. The next step is to add the electrode holder. Then I'll add the electrode user coordinate system to my preferred location at the reference origin of the holder. Now the electrode is complete. We can create a mirror to burn the other side of the part. Next, I'll show all the user coordinate systems for each part and copy the electrodes to each cavity. Before we go any farther, I'll go ahead and run an interference check to verify my work. No interference was detected. So let's try a slightly different approach. I'll hide the electrodes and use the extract electrode function again. I'll drop a blank over cavity 1 and verify the surfaces I plan to use. Then after the middle mouse button, let's fit and center the blank. But to make this electrode a bit more efficient, let's make it a multi-hit with mirrored geometry included. To do this, I need to enlarge the blank and shift it over. Now I can OK the electrode. Again, the system adds the electrode to the assembly and activates it so I can complete the design. I'll start with the blank and then add 2 composite curves. Then I'll create extensions like before, but for the second, I'll add a filler face to cap the end. Next, I'll build the extension to the base, cap the rib, and stitch it together to make it a solid. Next, add the holder and the electrode user coordinate system. Let's mirror the geometry. Then I'll adjust the length of the first extension so the copies intersect. Next, I'll create a radial copy and remove the unnecessary notch. This electrode does not require a mirrored counterpart because I mirrored the geometry on the electrode for a second location. So I'll add the new location and copy to the other cavities. Now I'll run an interference check. No interference was detected. Thanks for watching this brief introduction. Join me next time for designing electrodes with solid functions, electrode templates for design, and 3D trajectory.